Good evening to everyone. Today we are going to see the problems on EMF equation of a transformer. So coming to the first problem, a single phase transformer has 350 primary and 1050 secondary terms. The primary is connected to 400 volts 50 Hz AC supply. If the net cross-sectional area of the core is 50 centimeters square, calculate the first one is the maximum value of the flux density in the core, and the second one is the induced EMF in the secondary winding. Solution, given data. So in the problem, they given single phase transformer. So they given single phase transformer and they given 350 primary and 1050 secondary terms. So number of terms on number of primary terms N1 equal to 350 and number of terms on the secondary, that is N2 equal to 1050. The voltage applied to the primary, that is V1 equal to 400 volts. So now the induced EMF in the primary E1 equal to V1 equal to 400 volts. So they given supply frequency, that is F equal to 50 Hz. Supply frequency F equal to 50 Hz. So the next one they given the net cross-sectional area of the core. So the net cross-sectional area of the core A equal to 50 centimeters square. Now 1 centimeter equal to 10 to the power of minus 2 meter. So if you can substitute 1 centimeter here, so 50 into 10 to the power of minus 2 whole square. So you will get A equal to 50 into 10 to the power of minus 4 meters square. So calculate. The first one is the maximum value of the flux density in the core. That is Bm equal to question mark. And the second one is the induced EMF in the secondary winding. That is Et equal to question mark. We know that primary induced EMF E1 equal to 4.44 F pi M into N1. So why I consider here primary induced EMF means, so in the given data, E1 value is available, F value is available, so N1 value is available. So we know that pi m equal to Bm into A. So all the data is available. From that we can easily calculate Bm value. So that's why here I consider primary induced EMF E1 equal to 4.44 F pi m N1. So where pi m equal to Bm into A. Now if we substitute this one, E1 equal to 4.44 F Bm into A into N1. So the first one they are asking the maximum value of the flux density in the core, that is Bm equal to E1 divided by 4.44 F into A into N1. So you know the value of E1 value, that is 400 divided by 4.44 F value, supply frequency, that is 50. A value, that is 50 into 10 to the power of minus 4. And N1 value, that is 350. So now the Bm value is 1.0296 Weber per meter square or Tesla. So this is the value of maximum value of the flux density in the core. So in the second one, they're asking induced EMF in the secondary winding, that is E2. Now E2 equal to 4.44 F Bm into A into N2. So you know Bm value now. So all the data is available. Now you can substitute 4.44 into F value 50, you know the Bm value, that is 1.0296, and you know the A value, that is 50 into 10 to the power of minus 4, and you know the N2 value 400. So you will get 1200 volts. That is the E2 value. So in another way we can calculate E2, that is, we know that E2 by E1 equal to N2 by N1. Now E2 equal to N2 by N1 into E1. So you know the N2 value, N1 value as well as E1 value. So N2 is 1050, N1 is 350, and E1 is equal to 400. So after simplifying this one, you will get E2 value, that is 1200 volts. So this is the first problem. So coming to the second problem, so they given, so a 400 by 230 volts. That means they given E1 by E2, comma 50 Hz. That means supply frequency they given. So a single phase transformer has 250 turns on the low voltage side. That is secondary they given. So if the maximum value of the flux density in the core is 1.4 Weber per meter square. So they're asking calculate cross-sectional area of the core. And the second one is the primary number of terms. And third one is the transformation ratio. So given data, they given 400 divided by 230 volts, comma 50 hertz, single phase transformer they given. So primary induced EMF E1 equal to V1 equal to 400 volts. So secondary induced EMF E2 equal to V2 equal to 230 volts. So they given supply frequency that is F equal to 50 hertz. So on they mention single phase transformer. So the next one they given 250 turns on the low voltage side. That is number of turns on the secondary. That is low voltage side NT equal to 250. Now they given maximum flux density in the core. That is Bm equal to 1.4 Weber per meter square. Supply frequency they given that is 50 Hz. They're asking calculate cross-sectional area of the core A equal to question mark. The second one is the primary number of terms N1 equal to question mark. And third one is the transformation ratio K equal to question mark. So we know that the secondary induced EMF E2 equal to 4.44 F pi m N2 volts. So where pi m equal to Bm into A. So now you can substitute Bm into A. So in the problem they are asking cross-sectional area of the core. Now the cross-sectional area of the core A equal to E2 by 4.44 F Bm into N2. If you substitute E2 value F and Bm and N2 value, you will get A value. So E2 230 divided by 4.4, F value 50, Bm value 1.4 and N2 value 250. So after simplifying this one, you will get the cross-sectional area of the core is 2.96 into 10 to the power minus 3 meters square. So the second one is primary number of terms. That is N1 equal to E1 divided by E2 into N2 equal to V1 divided by V2 into N2. So if you substitute E1 and E2, you will get into and N2 value, you will get N1 value. So E1 value is the 400 divided by E2 is 230 and N2 is 250. Now N1 value is the 434.78 tons. So the next one they are asking to calculate transformation ratio that is K. E2 K equal to E2 by E1 and V2 by V1 and I1 by I2. So K equal to 230 divided by 400 volts, you will get 0.575. So if you substitute V2 by V1 also, you will get same value. If you substitute I1 by I2 also, you will get same value. So this is about the problem 2.